How's it going, everyone? Eulier Gonzalez again. Today we're gonna take a look now at a couple concepts, especially for the enterprise UI development. And anytime we talk about enterprise, it means big, huge, galactic. No. So this course is taught by Steve Kinney, the head front-end engineer at Temporal. He previously worked at Twilio and other several companies. So the entire reason is, or the goal of this course is, based on his experience, how can we make sure that our large code bases can still be maintainable over a long period of time with a wide range of collaborators and contributors in large teams. So why this is important? Well, because after all, if you're going to provide your service, especially from React, as a front-end developer, as a senior developer, okay, if you're going to provide your service, it is important to understand and for you to provide is a set of tools and installations needed to make the business or the company applications much more easy to do. So this is something that a lot of large companies actually are struggling. That's why they have this microservice and monolithic architecture. They just want to find a way to ship more. And companies, big companies like perhaps Google and Microsoft, most likely Google, they actually find themselves, they are so massive and gigantic that they barely can actually do something without breaking the entire thing, the code base. So again, because this is very narrow specific to the UI development, most of the time we know what maintainability means in backend services, right? So we have now the ability to add more features and to fix and to change that kind of thing. And we know what scalability means in the backend, all right? But when it comes to actually talk about scalability in frontend, a lot of the time that's actually something that you don't know, or you don't know what, or it's not well discussed, I will argue. But this I want to make this to serve as an example that, because we know what scalability means in backend, is like, hey, let's go to now sharding or do vertical or horizontal scaling. Let's going to use now some proxies or API rate limiting, that kind of thing. So split everything in microservice, right? So the front thing is the way of how you can extract that to the user. That's one of them. And the other is that we need to find a way, as I mentioned before, that how to make all of these installations, how to make all of this infrastructure, make it easy for us to add and fix things on the fly. So because now the specific thing that we're gonna look here is like, well, a comprehensible testing, which is the unit testing, the component testing, as well as the browser-based integration testing using Playwright, and it's trying to keep your code maintainable over a long run. Techniques or strategy that we're going to look at how to make our code much more easy to work with and to collaborate it. This is the infrastructure. And talking about infrastructure, we're gonna see now how can we actually automate certain process. along the way. So, for example, automation using GitHub Actions, as well as some patterns or some opinionated recommendations to build solid foundations for this enterprise UI development. So, because in today's video I want to now focus my attention on the introductions as well as the basic of the unit testing. But this introduction is more like to understand what is the end goal of this course, one, and what is the storytelling here that actually makes sense when it comes to build this infrastructure. It comes to build now maintainable code bases over a long period of time with a wide range of collaborators in large teams. So for that, well, this course is to actually know how to build the infrastructure needed to maintain those large code bases supported by a team of contributors. So this infrastructure, we need to understand what a couple concepts here. For example, like infrastructure. This course or these tools are for those that, for example, they inherit some old code bases, which is in my case, yes. Oh yes. If you inherit an older code base, that might be a good reason of how you can actually add this infrastructure. Maybe there's some change in product directions. So what started as a POC or a proof of concept from the product manager or the product owner, and then now we realize that the CEO actually wants to ship that. Well, we actually need to do that. The other is that when we need to migrate, or most likely that when you need to migrate or update from an older framework to whatever is hot this day. And this is something that you're going to see a lot of the time. Even though when I go out and understand what are the client needs, especially by listening to what they want, and I think that based on what they mentioned, is like, they actually need someone that not only can work with older code bases as well, and meaning that if they have that, so they have now the privilege to work on this not only large code bases, but also what does it mean is that their business is a good business or it's a strong business, and also you need to actually help them to migrate to new frameworks, right, or to new tools. Right now, perhaps they need to update the dependencies, okay, and then you need to lay out the infrastructure or all the basic installations needed to operate for its economy, for its household management. So, and the other is that maybe you're breaking ground on a brand new project and you want to get started on the right foot. This is something that is less likely to happen unless they give you, for example, a company or even yourself actually say, hey, you know what, we're gonna do this. We're gonna definitely going to do this, and that's it. So, what we're going to cover? First is the fundamental of philosophy of unit testing for your application, okay? Some strategy for testing your components, and here in the fundamental of philosophy of understanding unit testing of your application, as well as some strategy for testing your components, is most likely what is the reason of doing this kind of testing. What is the purpose of doing this kind of testing? It's similar to how to write browser integration tests with Playwright. Most of the time, those integration tests are brittle, but here we're gonna see how can we, for at least, implement that. Talking about brittle tests is that how and when not to fake stuff, because most of the time we love, if we can live in this world, things will be wonderful. The problem is that you can do that for third-party services, but if you're doing that for your own services or for your own code, there's something wrong. So we're gonna see how and when not to fake stuff. So for example, with mock stops and easy to test and update, and how to enforce coding practice or coding standards by using is the build process. So if you find yourself locally running npm tests, again, there is something wrong with that. You shouldn't do that. And that's what we are going to see is now the CI/CD process using GitHub Action, which is something that I'm quite familiar with. So this is it, right? So this is the introduction, right? Now for real. So this is the infrastructure here. So what's enterprise UI development? All right. What's enterprise UI development? Let's start with this.
Write to a complicated code base. Create maintainable code bases.
Some core question. Exactly. Some core question. Some core questions that may or may not have answers. That may or not have answers, right? How do we create maintainable code bases, but like in reality, when they grow? To put another way, how to hold back entropy? What does it even mean to be maintainable? So it's like, how do we create maintainable code bases? How do we create maintainable code bases as well, right? Maintainable code bases, but like in reality when they grow. But like in reality when they grow. To put another way, how to hold back entropy? To put another way, how to hold back entropy if this is possible. What does it even mean to be maintainable? What does it even mean to be maintainable? All right.
The kind of core questions that we're going to look at is how do we create maintainable code bases? I think a lot about when I started at my current job. One of the super duper senior distributed system engineers went like, find an architect. what is that? Right? And it made me think a little bit about like, what does it mean for a front-end app to scale? Right? Because like a database might have a million users, 100,000 users slamming at it, right? Your front-end application, generally speaking, they download the code into their one browser, and sure, could be Internet Explorer or Safari, depending on the year. But generally speaking, like the idea of like a million people using it, it's not necessarily going to have a larger effect than one or two, depending on like, other than the breadth of the different situations that they're using it in. So the way that I kind of explained the like plight of maintaining a large front-end code base, as I was like, you know how on the back end y'all like to break everything into very small microservices that don't know anything about anything and are totally isolated and encapsulated? He's like, yeah. I'm like, my job is to hide that from our customers. Right? They should never know that you did that. Right? And so the way I think that a lot of times a large front-end code base tends to fall apart is not necessarily that it goes down like a database, right? Or stops taking requests. It's usually that it slowly erodes and like kind of like in like physics, like everything tends towards entropy, which is like chaos, right? It slowly erodes to the fact that that one like what should have been a 1-point ticket or a 3-point ticket, right? A relatively easy thing to do. Everyone's like, I don't know, that might take 2 weeks, right? Because we don't know what'll break. And every time you like try to like push something in production, someone's pager goes off, right? Insofar that we build these like large like stateful applications, the way that they tend to like break down on us is that they become so complex and so complicated and so chaotic that they become almost impossible to maintain. And that's when people start whispering about the rewrite. And I've done the rewrite. The rewrite never goes well. Right? Like it's just a new opportunity to make the same mistakes and start the process over again. We will end up back there as well. And that is kind of what we are seeking in our time together, in this course, is to basically figure out how, to the best of our ability, how do we kind of like manage that chaos and keep it under control. Like I said, like even as I was putting all this together, like, and over the course of the last 6 months, like even in my relatively not particularly old, and it's open source code base, I can't really hide anything from you. I've noticed like, there are things where like we need to like focus on the testing over here. Or we need to, after we get all the lint errors handled and all the accessibility is handled, then that needs to actually break the build. But you can't break it in the very beginning because then you would never ship again, right? And so how do you kind of manage these things? Because they exist in new code bases and they absolutely exist in big code bases. If they don't exist in your code base, either you are the greatest front-end engineer and you're probably alone, because like, or you work on the greatest team possible, or it is so new and so small that you just haven't gotten there yet, right? And so that's great. Also, you should hang around because like maybe we can talk about how to make sure that you don't end up there, right? Because like for all these things, right? Like each time that I've done this, it is you're always trying to push back the ocean with a broom. But these strategies over time.
That was interesting. It's like you talk about you put the ocean, you put in the ocean
right? Like each time that I've done this, it is you're always trying to push back the ocean with a broom.
You're always trying to push back the ocean with a broom, bro. Oh my god, that's one of the. Oh, it might. It's like, are you mad? In Spanish is, tú eres loco, le pasas coleta al río. Are you mad or you trying to push back the ocean with a broom?
But these strategies over time start to add up, and you do have a code base that you're relatively happy working in, right? So yeah. So as I kind of said, right, like it's probably hard to like define.
All right, so you mentioned from this 3 minutes something quite interesting. You mentioned something quite interesting because it was like, what does it mean, especially here when you initiate this talk, right?
I think a lot about when I started at my current job. One of these super duper senior distributed system engineers went like, front-end architect, what is that? Right? And it made me think a little bit.
another senior.
The kind of core questions that we're going to look at is how do we create maintainable code bases? I think a lot about when I started at my current job. One of these super duper senior distributed system engineers went like, find an architect. What is that? Right.
You know, another senior engineer asked to you for this front-end architect. What is that? You know, exactly.
Right. And it made me think a little bit about like what does it mean for a front-end app to scale, right?
Exactly. So what exactly? So what does it? So what does it mean for front-end app to scale, for front-end apps to scale, right?
Because like a database might have a million users, 100,000 users slamming at it, right?
Exactly. So because that's right, because a database can have 100 users slamming at
your front-end application. Generally speaking, they download the code into their one browser.
Mm-hmm. So because database can have 100 users landing at, your front-end app is just code that one browser download.
Sure, could be Internet Explorer or Safari, depending on the year. But generally speaking, like the idea of like a million people using it is not necessarily going to have a larger effect than one or two, depending on like other than the breadth of the different situations that they're using it in.
So yeah, it's like just one code that one browser download. Exactly, because database can have 100 users slamming it. And you front-end app is just code that one browser download. Depending on the browser. But that doesn't impact.
So the way that a million people using it is not necessarily going to have a larger effect than one or two, depending on like other than the breadth of the different situations.
Yeah, exactly. Depending on the browser. Internet Explorer or Safari, but it doesn't have an effect.
Using it in. So the way that I kind of explained the like plight of maintaining a large front-end code base, as I was like, you know how on the back end.
But it doesn't impact directly on how many million users. Yeah, but it doesn't impact directly on how many users. And how many users use it, despite the breadth of the browsers. So one way to explain.
Again, you all like to break everything into very small microservices that don't know anything about anything and are totally isolated and encapsulated. He's like, yeah. Like, my job is to hide that from our customers.
So one way to explain what front-end
small kind of explained the like plight of maintaining.
Plight. What in the F is plight? Oh, okay. El apuro, la situación. the situation, the plight. Ok, una situación precaria, the plight. El apuro. Okay, so we're going to explain the plight of front end.
One or two, depending on other than the breadth of the different situations that they're using it in. So the way that I kind of explained the plight of maintaining a large.
Exactly. So one way to explain the plight of maintaining large front end code bases is like for backend developers.
Front end code base, as I was like, you know how on the back end y'all.
You know how is the backend isolated? You know, what is it? You know how is the backend? How how in backend everything is a microservice, which is something, again, it shouldn't be that. you know how in backend everything is a microservice that is isolated and can talk to each other.
I like to break everything into very small microservices.
Exactly. Exactly. So how in backing everything, you want to split everything into microservices that are isolated and encapsulated. That are isolated and encapsulated.
That don't know anything about anything and are totally isolated in a encapsulated base. As I was like, you know how on the back end y'all like to.
Okay. So how in the back end everything you want to split. You know that in the back end, that in backing everything, you split everything into microservices that don't know anything about the rest.
Break everything into very small microservices that don't know anything about anything.
Exactly, that don't know anything about anything and are isolated and encapsulated. The front end work is to isolate that. The front end work is to isolate that from the customer. Exactly, the customers only don't care about that. It's like, no, I actually give it to me in a very friendly user way. It's like, yeah.
And are totally isolated and encapsulated. He's like, yeah. Like, my job is to hide that from our customers. Right? They should never know that you did that. Right? And so the way I think that a lot of times a large front-end code base tends to fall apart is not necessarily that it goes down like a.
And the front-end work is to isolate that. So the front-end work is to isolate that from the customer
database. Right, or stops taking requests. It's usually that it slowly erodes and in physics, like everything tends towards entropy, which is like chaos, right? It slowly erodes to the fact that one, which should have been a 1-point ticket or a 3-point ticket, right? A relatively easy thing to do. Everyone's like, I don't know, that might take 2 weeks, right? Because we don't know what'll break. And every time you try to push something in production, someone's pager goes off. Right? Insofar that we build these large stateful applications.
So the front end work is to isolate that from customers. So the connection here is that because we're talking about is now how you can explain that to a college, all right? Which is when you everything, that in the backend you split everything into these small tiny microservices that they don't know about each other, that they don't know anything about anything, and they are isolated and encapsulated. Well, my job is to hide the front end job is to hide that from customers, which what happens is that it slowly erodes
and fall apart is hide that from our customers. Right? They should never know that you did that. Right? And so the way I think that a lot of times a large front-end code base tends to fall apart is not just
and a lot of the time that front end code falls apart is not because the database goes down. It that slowly erodes to the point that making small changes. He describes something here. It slowly erodes at making some front end changes. Slowly erode to the point that making small changes is something difficult without breaking anything, without breaking something. Especially for the front end.
Necessarily that it goes down like a database, right? Or stops taking requests. It's usually that it slowly erodes and in physics, like everything tends towards entropy, which is like chaos, right? It slowly erodes to the fact that one, which should have been a 1-point ticket or a 3-point ticket, right? A relatively easy thing to do. Everyone's like, I don't know, that might take 2 weeks, right? Because we don't know what'll break. And every time you try to push something in production, someone's pager goes off, right? Insofar that we build these large stateful applications, the way that they tend to break down on us is that they become so complex and so complicated and so chaotic that they become almost impossible to maintain. And that's when people start whispering about the rewrite.
So as the code base grows and evolves, it slowly becomes quite hard in terms of time. As the code base grows and evolves, it slowly becomes quite hard in terms of time to add something or to change something. That's when people start to talk about rewrites, and rewrites never go well. And rewrite never go well.
I've done the rewrite. The rewrite never goes well. Right. It's just a way.
And rewrites never go away. It's it's just an opportunity to make the same mistakes.
It's just a new opportunity to make the same mistakes and start the process over again.
It's just an opportunity to make the same mistake and start the process all over again.
And we will end up back there as well. And that is kind of what we are seeking in our time together, in this course, is to basically figure out how, to the best of our ability, how do we kind of like manage that chaos and keep it under control. Like I said, like.
So the goal here is to see how can we keep that chaos under control to our best of our capabilities.
Even as I was putting all this together, like, and over the course of the last 6 months, like, even in my relatively not particularly old, and it's open source code base, so I can't really hide anything from you. I've noticed like, there are things where like we need to like focus on the testing over here, or we need to, after we get all the lint errors handled and all the accessibility is handled, then that needs to actually break the build. But you can't break it in the very beginning because then you would never ship again, right? And so how do you kind of manage these things? Because they exist in new code bases and they absolutely exist in big code bases, and they don't exist in your code base. Either you are the greatest front-end engineer and you're probably alone, because like, or you work on the greatest team possible, or it is so new and so small that you just haven't gotten there yet, right? And so that's great. Also, you should hang around because like maybe we can talk about how to make sure that you don't end up there, right? Because like for all these things, right? Like each time that I've done this, you're always trying to push back the ocean with a broom, but these strategies over time start to add up, and you do have a code base.
It is interesting. So each time you're trying to do this, it's like pushing the ocean back with a broom. But even though this is strategy, so these strategies provide now some confidence. So this strategy provide now code bases. So this strategy provide now code bases that are relatively easy, relatively easy to work with.
That you're relatively happy working in, right? So
easy to work with. Exactly.
As I kind of said, right? Like it's probably hard to like define what it means to build a maintainable application as we spend the next like several hours together talking about how to build a maintainable application. Like the best way to talk about it is to talk about what it's not. Right? Like if you feel like you can't ship anything without being worried that something else is going to pop off the other end and break, then your app is probably not maintainable. Like you literally can't maintain it. You want to be able to change stuff and confidently know you didn't break something, right? It's one thing, like step one, you would love to change something and have nothing break. Step two, or like second best, is you'd at least like to know before your customers find out, right? I joke that like you always have tests, right? It's easy to have automated ones that run lightning fast. You're doing it yourself, or your customers are doing it for you. Somebody is testing the software one way or the other. Maybe you want to refactor without overwhelming fear. Like you know that you need to like sit down and take a step back and think about this when a new version of whatever framework or even some library that you're using comes out and someone's like, should we upgrade? And you're like, should we upgrade? Absolutely. Can we upgrade? No. And like over the fear around them, like let's wait until like Thanksgiving break or like the end of December to upgrade. That's when you start to know that like it is time to like think about some of these things. Like updating dependencies and knowing that everything works without having to go testing your very small to-do list app. Of course, you can do that. Even then, like, can become tricky. Testing any kind of like decently large application, like that becomes like an all hands on deck. Like the team is kicking it for like 2 weeks, which is not the best use of anyone's time. And the theme that we're going to come across, kind of deal with, today is basically how do we automate this? How do we basically have processes and infrastructure that is making sure that we can feel confident? And like, yes, we should always have the human element there, right? Code reviews are great. They don't always work at scale. Like there's always like whenever there's a bug, like there's the joke to like get blame who the last person touched it. It's like my thing is like, well, who read the code review? Like who approved it? And I am guilty of this, right? Like sometimes you're tired, you don't have the same attention to detail, probably like the person who wrote it. Sometimes you just feel bad because you've been really nitpicky over things, right? And you kind of like, you get to the point where it's like either this ships or it doesn't, right? And so code reviews obviously are a thing, but then like, can we build the infrastructure around it so that like we're talking about like more forward-thinking and high-level things rather than like you have an extra space after that like opening bracket, right? Like have something deal with that for you, right? That's not a good use of anyone's time. Cool. And so again, this theme of like automation. If I had to, and I did have to because I prepared for this, think about like what are all the components of like a well-architected, and that's a word that I don't love, but I stole from Amazon, in terms of their like cloud services. Like what are the pieces of a decent like front-end architecture that you need to have kind of in place to be able to consistently ship software? Testing, right? Like all sorts of different kinds of testing, like some of these are more possible than others, just to kind of make sure that everything works because like I said, either you do it or you automate it. I think one of the nice things in the modern era is like a lot of the tooling around this stuff is a lot better. Like I would argue that TypeScript, for instance, like takes out an entire like class of tests that I used to write that I still occasionally write because like we trust that our APIs stay the same, but like we don't really know that, right? Like just because your type doesn't have like undefined or null, that doesn't mean that the API didn't give you that. Some of the worst bugs I've ever seen was a well-meaning backend engineer accidentally shipping a breaking change to the API, right? But generally speaking, if you think about what TypeScript is, right, and we're not going to get all the way into the weeds on this, but there's a certain spiritual aspect of it that is running through your entire code base, making sure that you pass any given function something that it expects, right? And yelling at you when you're unclear about that, right? That takes away the entire set of tests where it's like, you pass null into the function to see what happens, and then you pass all sorts of other bogus inputs, right? Like, that can still happen because it's JavaScript at the end of the day, but like, there's an entire, set of tests that like will help in that case, right? Linting, and like linting's tricky because there's like, the stylistic ones, which I'm not super interested in. One of the things that I've had to learn to do over time is like let go of my stylistic preferences and like it's okay if someone uses a function declaration and somebody else uses a function expression. It's going to be all right. That's not going to be the thing that stops you from shipping stuff. That said, there are things in your linting that like you might want to avoid like unnecessarily like confusing like for loops or something along those lines. A really great example that I think a lot about is, for instance, we have an abstraction for making API requests. And yeah, under the hood, it's just using fetch, sure. But it's also doing things like, well, if there is an error, right? Go ahead and like bubble that up to like Sentry, which is what we use to track like errors in production, right? And then maybe it's got some retry logic. And like generally speaking, it's also got like types for the different endpoints that can hit, so you don't like mistype the URL and find something. It's got a whole bunch of like features, and we'll go ahead and like we have cursor-based pagination, so on and so forth, right? You should use that instead of using fetch, right? If you're working in the application that I work on. However, like there's not really a test that's going to catch that. right? That becomes the static analysis. Like, hey, I noticed you use fetch here. Like, maybe you should, you can opt out of it if there's a really good reason. But like, let's automatically check. Like, maybe you're brand new. Maybe you're just like switching in from another code base, and you don't know everything because we should document everything except nobody reads it. And goes ahead and just like kind of informs and helps guide the maintainability of your code base, because that's one of those things where a well-meaning mistake where somebody didn't know is all of a sudden, hey, when you're like going to the postmortem and you don't have any logs because maybe the rejected promise didn't bubble up to your like error reporting tools. Formatting, like I think that like just set Prettier up and let it do its thing and never have these conversations again is a world that I like to live in. The kind of one of the major things, like testing is obviously going to be a huge part of our time together. All sorts of testing, all the different flavors of testing. That said, if you have to run npm test, you're missing the point. Right. So there should be some process that will go ahead and check the lint. There's some process that goes ahead and runs the test for you on every like push to a PR or something along those lines. So we'll talk a little bit about how to set that up. And like we're gonna use GitHub Actions, which is like wildly powerful for a somewhat free-ish tool, free on an open source repo, relatively cheap on a private repo. You can do really cool things like have it automatically open issues for you. We have it set that when we bump the version on the open source UI, it will automatically open up a PR on our SaaS offering with a new version of that, like, and run the tests there as well. There's like, a lot of this stuff will be bespoke to the unique needs that you have to solve for, but we'll kind of talk about like the wide range of possibilities. And my goal is we'll do the kind of obvious things that like everyone should do, but we'll also kind of explore some of the like interesting recipes and edge cases. And my goal is that like a week from now or like 2 weeks from now, you're walking down the street and you're like, oh, I could take this tedious manual process and put together a GitHub Action workflow. And if you use some other CI/CD tool, that too, whatever. Like that'll all work, but like something to like think about what are all of the annoying things that you do, right? And when we get to the like processes, I'll round back to deployment infrastructure in a second. The processes, which is like, okay, like how do we design new features? Do we have a process for writing a design?
Exactly. And I think that's quite interesting. I think from all of this check-ins and security guidelines and quality control, blah 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 blah, right? So for all of this type of testings and static analysis, building process. And separation of concerns to keep your business logic separate from the view layer, and then how you going to deploy that, and some of this nice little feature free-ish provided by GitHub as a way to actually do that, to check to run testings as well as static analysis and build process, and how you can now test the separations, or how you can test now business logic, right? And how you can make everything inside of this deployment infrastructure, okay, before actually push that to productions. So with that, we need to find a ways how we need a process or design a process of how we're gonna actually ship code, how we're gonna actually how is our process to build new features. And I think this is somewhat interesting, because at the end of the day, users will demand some features, or you fix that, and you need to have a system for that. Or for writing documentations as well.
Document who reviews those, right? Those things are also really key to the maintainability of your code base as well. On those like build processes and systems and stuff along those lines, like as it stands right now, we do this thing where it's like we're going to release every Monday. It's an hour meeting with the goal to cut it down to 15 minutes. Right, so every manual step, someone's taking a note of like, how can we automate this? Right, and that's going to be some of the stuff we look at today as well. And then we have that kind of structure. Does our view layer sit there and process a bunch of data and make a bunch of API requests? Well, that's going to be hard to test, right? And we'll kind of see that in some cases, right? Like, do we, what is our deployment infrastructure? That's going to be unique to every company you work at. Well, at least, talk about it at a high level. We talk a lot about like technical debt. The other kind of thing that I want to like highlight is there's also this cognitive cost, right, to a complicated code base, right? If you know that all of your if you follow, whether it's a pattern like MVC, which is, whatever, some pattern where okay, all of the business logic is here, all of the fetching and massaging the data is over here, all of the view layers over here. We have that kind of set up, and you kind of know where to go looking for something, right? That makes you way more productive in a code base than everything kind of jammed together. When we talk about testing, kind of one of the heuristics that I'm going to kind of use, which is if you have to mock and stub your own code, you've done something wrong, right? Third-party things you don't control, sure. But if you are all of a sudden I don't have access to that hook from outside the component or the Redux store or what have you, it doesn't really matter, and you find yourself mocking things that you own, right? That's a good sign that you have not separated these concerns. And kind of as I thought about it more and more, there are kind of the three levels, and this pyramid is designed after Maslow's hierarchy of needs, which is first have the systems in place, right? If you don't have the systems, then you can wax poetic from your ivory tower about the best way to structure an application. It doesn't really matter.
You can wax poetic, man. Wax poetic over your ivory tower, meaning to wax poetic to wax poetic means to speak in an increasingly enthusiastic poetic manner. Okay, I wax oh my god, yeah. Yeah, I do. To wax poetic exactly, to wax poetic, man. Over your ivory tower, no one cares. Wax poetic, man. Wax poetic. To wax poetic on. To wax poetic. To wax poetic from your ivory tower. God damn, son. And it is interesting because it actually is now using the SEO for that. Holy moly. Enterprise UI Dev. What is Enterprise UI Development? Plight. Un apuro. You're in a plight. Okay. A portrait of an artist as a young man. Wax poetic, bro. To become increasingly verbose, often derogative. To become increasingly verbose. Wax poetic. To wax. How common is wax poetic? Wax is pretty much limited to the moon. Wax poetic. Interesting. Interesting. To wax poetic. No, but that's a verb. Eloquent. Wax. To wax poetic. Yeah, to wax poetic in their ivory tower is like, well, okay. What in the French toast is? A substance that is secreted by bees. Okay, wax. It's like wax is like cera. Spanish. Exactly, it's like cera. And it's used by them for constructing the honeycomb. That is dull yellow solid plastic when warm, and that is composed primarily of a mixture of ester, hydrocarbon, and fatty acids. Fatty acids, interesting. Beeswax. Any of various substance resembling the wax of bee. Any number of substances of plant or animal origin that differ from fat is being less greasy, harder, and more brittle, and it contains principally compounds of high molecular weight, such as fatty acid, alcohol, and saturated hydrocarbons. Something likened to wax as soft, impressionable, or really molded, a waxy secretion. Earwax, a phonograph recording. To treat or rub with wax, usually for polishing, stiffening, or reducing friction. This is the verb. Okay, this is a noun. Okay, to describe something. And this is now to describe an action. To treat or rub, to apply, to record on phonograms record. Waxings and waxes. To increase in size, numbers, strength, prosperity, or intensity. To grow in volume or duration. To grow toward full development. To increase in the phase of intensity. Use chiefly of the moon, other satellites, and inferior planets. Inferior planets, or subplanet, or small planet. To assume a specific characteristic, quality, and state. But wax is not only is this substance secreted by bees as a noun, all right, but also is something that when you apply that, it can polish, stiffen, or reducing friction. Or when you're using plural, Mm-hmm. On the wax, on the growth, a feet of temperature, of temper, rage. But this is again British. So you wax. Oh my god. Okay, so on you wax on the ivory tower hour because that's something. Okay, blight and wax. That's quite interesting, man. That's very very interesting. That's very very interesting. Oh yeah, it is, man. Yeah, it is, bro. Mm-hmm. Okay, 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 okay. So you wax from your ivory
Right.
tower.
If you don't have like the systems, then like you can wax poetic from your
You can wax poetic. Okay. You can wax poetic from your ivory tower. No,
ivory tower about the best way to structure an application. It doesn't really matter.
about the best way to. You can wax poetic about the best way of how you can do that, but doesn't matter. You can wax poetic, man. Tú puedes hablar de manera elocuente, pero similar a lo que comenta Letra. Ese flow es ajeno. Te lo estoy diciendo, vas a terminar como el colgado, como el nazareno.
Also, you can like talk about it over lunch, but unless you actually have a process for like getting the team on board and all of those kinds of things, then like it doesn't matter either because it's just like your thoughts. And so like those patterns, those kind of like belief systems and how do we structure an application are like sit on the foundation of like do you have a system that keeps everyone honest about that? And do you have a process? Patterns, those kind of like belief systems and how do we structure an application are like sit on the foundation of like do you have a system that keeps everyone honest about that? And do you have a process for kind of collaboration? Otherwise those parts don't really matter. And so we will spend a lot of time focusing on the systems because one, that's the most subjective, right? Everyone's code base is going to be a little bit different. But we will, when possible, kind of talk about the processes and the patterns. With that, we will be, writing some code and tweaking some stuff, right? Like I went through my own code base and tried to find. At one point, I was just going to grab the entire open source code base, but I realized that like trying to grok that was a recipe of sadness. And I learned some things even trying to pull certain functions out about how I'm going to break a lot of my own rules. So I have a set of things to do for myself after putting this all together. But like trying to take some of those patterns into small, like grokkable pieces.
Okay.
Like the team is.
But again, the whole thing of this is to not only be able to describe is like what is this front end architecture means, right? Especially if you have to explain that to somebody else. It's like if you imagine. Do you know that in the backend we have everything split into more modular things called microservices that they don't know anything about anything, but they now live in this isolated. Yeah, but you can split everything into microservices that don't know anything about anything and are isolated and encapsulated. The role of the front-end engineers and architects are to hide that from the users. So the end user doesn't need to know what's going on. Right? This is it. Take care. Bye-bye. Okay? So what happened is that unlike backend applications that a lot of people are hammering into that database, and then you can scale that. In the case of the front end, you really don't care about that. Actually doesn't impact how many users actually go through that particular browser because they're just going to download that code in one browser or depend on the breadth of the browser. Safari, Internet Explorer, you name it. But for maintainability, okay, the front-end code becomes slowly erodes in a way that is one thing that is simple one simple task, it becomes quite unbearable to do that. So it takes time to actually make that happen. And that's when you started to realize that there are a couple of things that we cannot control, or when you discuss about that kind of thing, it's like you're trying to push the ocean back with a broom. But even though there are certain strategies that have at least proved to Steve Kinney when it comes to collaborate with these large front-end code bases, there are results into a more easy and fun way to do that. All right. So here, because sometimes people out there are starting to talk about rewrites, and rewrites never go well. It's just an opportunity to make new errors and start the process again. But even though, right, this strategy that at least for Steve Kinney has proved to make the collaboration across different teams somewhat easy to do, okay, relatively easy to work with. He described is the word maintainability. Okay, he described what is maintainability, but from another point of view, right? So to know how to make our code maintainable, okay, one way to look at it is what is the opposite, okay, as a way to understand that. And what is the maintainability words mean, right? Maintainable, that actually comes from the old French word maintenir, okay, which means to upkeep, shelter, and protections, to keep and sustain, to preserve in, right? And because again, the entire reason of today, or this goal, or the goal of this course, is to, well, build know how to build the infrastructure needed to make the code maintainable, to make large code bases maintainable over a long period of time with a wide range of collaborators in large team. So this concept of infrastructure is important to actually understand that, because that will lay out the foundation of what we are going to do. If you are quite familiar with some German words, I really love the German word, because despite that it's being long, there's a lot of long words in German. One of them is the Bushaltestelle. If you don't know German, it doesn't matter. The whole point of this is that inside of the word actually is pretty descriptive about what you mean. You know, for example, here's the Bus has the Bushaltestelle. What does it mean is, well, the boss, you gotta be, get out. No, come on, you son of a fucking bitch. Oh my, for real? Yeah, you know, is that Booth Hastings Daily, right? If you split this, all right, That particular words, if you can split this word, it's pretty self-descriptive. Okay, so the bus, you know, Halston is the act. It's like, hey, this is like stop here. And still stille, it means the place. If I got it right. So you say bold Hastel. You know, Halston. You know, Hastelstelle.
Haltestelle.
You know, it's pretty self-descriptive about that. There's some words in English as well that are like that, but I think the German actually have a lot of more words that are very explicit. That's what you can hear about that, like if they're angry. But they're not. They just actually putting all of these words and composing them in there. For example, butterfly, butterfly in German, right? Schmetterling.
Schmetterling.
Schmetterling. My question is that what is an Schmetterling? You know, what actually means method? No, doesn't mean anything. Okay. Schmetter. Okay. Schmetterling. Schmetterling. Yeah, perhaps that was not the best example of that. In any case, the whole point of this is to, why mention that kind of thing is like, yeah, it is important for us to now that we know what this word means, the infrastructure, okay, that come from the old French, or that come from the French, according to Etymology Online, the 1887, okay, which is the installation that formed the basics of any operations or systems for its economy. Initially, as initially or originally in a military sense, but now in an economic sense, right? And this foundation, or these basics installations needed for its operation, for its economy, which is economy is for it is household management, the frugality, the judicious use of resource. Here, the judicious use of resource in terms of how going to collaborate this. The judicious resource on how can we make these collaborations, how can we now integrate features or add some changes to that in the most performant way, right? So that actually shouldn't take that long. So I get it why a lot of this industry actually are using or creating is this particular technologies, Angular, React, or Angular, React, Vue, Svelte, that kind of thing, to actually aim to a particular target in the market. But again, it's trying to adding all of this layer of complexity that I think that, in any case, I go beyond the scope of this word. But in any case, the TLDR of that is the infrastructure. Know what's an infrastructure is, as well as the word economy, and a more practical sense of how you can apply that infrastructure to your life. So what is the basic installation that you need in your life as a way to do what you need to do for that? You need something, you need basic installation for sleep, eat, for sleep, eat, store food, store clothes, store water, store electricity, and now access to Wi-Fi. Basic stuff. And also, I will argue that do exercise. I will put it here right now. It's like exercise. It's like exercise. So there's a couple things that we need to do to maintain our system. Okay. So yeah, but because we are now making sense of how do we gonna reach here, especially when we talk about what is the UI enterprise, and we need to talk about it from the role of the front-end architects. So what is the front-end architect job at the end of the day? Is like, well, is to hide the complexity of the backend developers to our customers, and to do that because most of those code bases, unlike the database, right? Yeah. So most of those code bases, unlike so most of those code bases, yeah. So most of those code bases, most of those code bases, unlike the backend, where as a way to scale that, or to handle now scalability in that, you go into split. Since a lot of users can slammer in your database, that you know what to do about that by splitting into perhaps several microservices, or applying some vertical or horizontal scaling, and other techniques. Okay, what it means for the front end is that it's quite different. It's not how the clients are going to download, or how many users are going to access or download your code in their browsers. It's most likely that how often or how easy it is for us to make change in the code base. Is to make change in this front end code. And because as anything in life slowly erodes, at the point that one small ticket, one or three actually is causing, one or a ticket of one or three can slowly now make small changes take weeks. And that's when you started to realize, it's like, hey, well, this code is actually not maintainable. And that's when people started to whispering about rewrites, and rewrites never go well. Because you started to it's a new opportunity to make new mistakes. It's a new opportunity to make the same mistakes, setting up a new process that you went on to end up there. But in any case, the whole point of this is to describe what is maintainability. Okay? What is maintainability in a code, bro? That you can now easily is, what is maintainability in a code? Okay? Well, are you able to now change stuff? Are you able to now easily add new stuff or change it confidently without breaking something. Maybe you want to be able to refactor without overwhelming fear or updating dependency. If any of this question actually is yes, but no, can we do that? Yes. Should we do that? Yes. Can we do that? No. Then your code is not maintainable. So, what can we do to do that? Right? Some of them is, code review. So, what can we do to make it as human as possible, or to our best of our capabilities, to the best of our capabilities? Exactly. So how can we make it to the best of our capabilities? How can we do to make it maintainable to the best of our capabilities? Okay. Because it's this. Because the whole point of is this. So how can we make it maintainable to our best of our capability, that we can now easily add features, that we can is now change that confidently without breaking anything, that we can actually update that, which is something that we are going to do especially for that particular client. I'm definitely going to do that. Like, what are the things that you need to the best of our capabilities and to change that? Okay. And well, so is that now you have a testing area, as well as you have now a static analysis, so TypeScript linting, formatting, you have a build process, you have now separation of concern, that you keep your business logic separate from the view, and then you have now a deployment infrastructure to do that, and a design process, man. And a design process, this last piece, the design process is something to think about it, because it involve topics like what is the process, okay, of adding new features. Okay, so what is the process of adding new features?
Flavors of testing on those lines. Everyone should do. Process for writing a design document. Who reviews them? Come back to deployment infrastructure in a second. The processes, which is like, okay, like how do we design new features? Do we have?
How do we design exactly? How do we design new features?
Have a process for writing a design.
Do we have a process for writing the design document? Do we have a process for writing a design document? a design document.
Design document. Who reviews
Who
those, right?
reviews those? Who review those?
Those things are also really key to the maintainability of your code base as well. On those like build processes and systems and stuff along those lines, like as it stands right now, we do this thing where it's like we're going to release every Monday. It's an hour meeting with the goal to cut it down to 15 minutes. Right, so every manual step, someone's taking a note of like, how can we automate this? Right, and that's going to be some of the stuff we look at today as well. And then we have that kind of structure. Does our view layer sit there and process a bunch of data and make a bunch of API requests? Well, that's going to be hard to test, right? And we'll kind of see that in some cases, right? Like, do we, what is our deployment infrastructure? That's going to be unique to every company you work at. Well, at least, talk about it at a high level. We talk a lot about like technical debt. The other kind of thing that I want to like highlight is there's also this cognitive cost, right, to a complicated code base, right? If you know that all of your like, if you follow, whether it's a pattern like MVC, which is, whatever, some pattern where okay, all of the business logic is here, all of the like fetching and like massaging the data is over here, all of the view layers over here, we have that kind of like set up and you kind of know where to go looking for something, right? That makes you way more productive in a code base than like everything kind of jammed together. Layers over here, we have that kind of like set up and you kind of know where to go. Business logic is here, all of the like fetching and like massaging the data is over here, all of the view layers over here, we have that kind of like set up and you kind of know where to go looking for something, right? That makes you way more productive in a code base than like everything kind of jammed together. When we talk about testing, kind of one of the heuristics that I'm going to kind of use, which is if you have to mock and stub your own code, you've done something wrong, right? Like third-party things you don't control, sure. But if you are all of a sudden like, I don't have access to like that hook from outside the component or like the Redux store or what have you, it doesn't really matter. And you find yourself like mocking things that you own, right? That's a good sign that you have not separated these concerns. And kind of as I thought about it more and more, there are kind of like the three jammed together. When we talk about testing, kind of one of the heuristics that I'm going to kind of use, which is if you have to mock and stub your own code,
yeah, the design process is something to think about. It involves topics like this. How do we design new features? How do we have a process for writing a design document? And who reviews that?
You've done something wrong, right? Like third-party things you don't control, sure. But if you are all of a sudden like, I don't have access to... And kind of as I thought about it more and more, there are kind of like the three levels, and this pyramid is like designed after like Maslow's hierarchy of needs, which is like first have the systems in place, right? If you don't have like the systems, then like you can wax poetic from your ivory tower about the best way to structure an application. It doesn't really matter. Also, you can like talk about it over lunch, but unless you actually have a process for like getting the team on board and all of those kinds of things, then like it doesn't matter either because it's just like your thoughts. And so like those patterns, those kind of like belief systems and how do we structure an application are like sit on the foundation of like, do you have a system that keeps everyone honest about that? And do you have a process for kind of collaboration? Otherwise, those parts don't really matter. And so we will spend a lot of time focusing on the systems because one, that's the most subjective. Right, everyone's code base is going to be a little bit different, but we will, when possible, kind of talk about the processes and the patterns. With that, we will be, writing some code and tweaking some stuff. Right, like I went through my own code base and tried to find. At one point, I was just going to grab the entire open source code base. So I realized that like trying to grok that was a recipe of sadness, and I learned some things even trying to pull certain functions out about how I'm going to break a lot of my own rules. So I have a set of things to do for myself after putting this all together. But like trying to take some of those patterns into small, like grokkable pieces. So we will be kind of objectively. It's not going to be like hours upon hours of me waxing poetic from my ivory tower. But we'll kind of look at some of these, particularly with the systems, with some small, bite-sized little sample applications.
All right. Okay. So that'll be all for this video. Take care.